So exponential functions are any functions that are going to have x in the exponent. Okay, so this is going to be y equals a to the x. So if you have a variable in the exponent, that is an exponential function. So for example, this is a graph of 2 to the x power. We're going to start at 2, not 1, because 1 to any power is still 1, which makes it not exponential. For this example here, okay, as I plug values in for 2, I have 2, the first is 2, 2 squared, 4, 2 cubed, 8, and it would keep going up. And then this is what your graph looks like, okay? The y-intercept would be 0, 1, because anything to the 0 power is 1. The domain here is going to keep extending, okay, to the left and up, so negative infinity to infinity. And the range is going to be 0 to infinity because we're not going to cross the x-axis. So we can do some transformations here with this graph. Okay, if I take the graph of negative 2 to the x plus 3, let's just take a look at what that looks like. And then you can see where the transformations happen. So if I put this in here, I've got a negative 2 to the x value, and then plus 3. Okay, so here's what my graph looks like. And if you look at, we can make another one, which is 2 to the x. So you can see they are going to be flipped, okay, about the x-axis, with respect to the x-axis, because this is positive, this is negative, going down. And we're taking this and we are shifting it up 3 values. This is that plus 3 here. So this goes up 3 values. So you can kind of look here, if you were to do a table, you can take a look at the table. Okay, when I plug negative 1 in here, I'm going to get 2.5. Okay, if I plug 2 in here, I've got negative 2 squared. So that's going to give me, the negative is in front of the 2. So negative 4 plus 1 would give me that negative 1. And you can plug some values in here and kind of see what's going to happen as you go down the graph. Okay, so that's just looking at the exponential graph of what happened. And then the domain and range, if you look at the graph again, the domain still is negative infinity to infinity. You're just going to have a different range here. So this range is going to go from positive 3 up to positive 3. So negative infinity to positive 3 here, because you've got this asymptote of positive 3 here, where we're not crossing. If you take a look at these points, you're not going to pass this positive 3 point as you keep going. So a lot of that you can just plug in and take a look at, and then you can write that down. So, and domain, negative infinity to infinity, range, negative infinity to positive 3, and then our asymptote, we did have one at y equals 3, that horizontal line at 3 there. So if I look at this, if you just look at what's happening with the y values, this is linear, exponential, or neither. Exponential. So this is exponential. So then you would take this model, y equals a to the x, and pick a point and plug it in. Okay, so let's say we pick this point here. Okay, so y is 81. You need to find a, and then your x is 2. So what squared equals 81? Yep, you say then that's 9. And if you can't find it, then you would just take the square root. And you would say that 9 equals a. So then the equation for this function is going to be y equals 9 to the x. So that's just a little bit about graphing. We're not going to be super concerned with graphing. I want to be doing more of the equations, solving these equations here. So solving exponential equations, we're going to get to here. So when you have a problem that has a variable in the exponent, If you can do this procedure, you will. If you can't, you're going to go to logarithms, which we'll do in the next section. Okay, so here, if you can find a common root for the bases, this is what you'll do. There is no common root, then you do logarithms. So for here, 25 and 125 share a common root, which is 5. 5, yes. So we say, all right, 25, let's see, the square root of 25 is 5, and the cube root of 125 is 5. So you have to know your roots here to kind of be able to look at these. So you're going to rewrite them as powers of 5, meaning you're going to write 25 as 5 squared, and you're going to write 125 as 5 cubed. And then you would bring down whatever's left at the problem. So there's an x, that comes here. Okay, then since the bases are the same, cross out the bases, set the exponents equal to each other, and solve. So here I'm going to divide both sides by 2. I'm going to get x equals 3 over 2. And then you can check that if you want. 25 to the 3 over 2. So 25 to the 3 over 2 gives you 125. So when you look at example 5, think of a common root here. So I know if I took the square root of 9, that would be 3. Is 3 a root of 27? Yeah, so 3 cubed is 27, and 3 squared is 9. So we're going to use that to solve this problem. So we're going to rewrite 27 as 3 cubed, and then you just bring down that 2x, put it next to it, and then rewrite 9 as 3 squared. When you bring down the x plus 1, just make sure you put that in parentheses. Then cross out the 3's, and then solve this. So 3 times 2x would be a 6x. 2 times x plus 1 is going to be 2x plus 2. And then we will solve. So we will subtract the 2x. That's going to give us 4x equals 2. Divide by 4. Get x equals 2 over 4, or 1/2. Okay, so let's take a look at example 6. So this is a little bit tricky here. So 5 and 6 don't have any roots, right? Okay, so think automatically to how they relate to the next one. Okay, now this is 216, which relates to 6, and 5 relates to 125, right? So we know this. 5 cubed is 125. 6 cubed is 216. So let's start rewriting it like this. You've got 5/6 to the x equals, let's see, 216 is 6 cubed, and 125 is 5 cubed. The problem here is the bases still are not the same. How did they get switched like that? Do you guys remember exponent rules, how they would switch? It would be a negative exponent. So if I did 6 to the negative 3 and 5 to the negative 3, then I could switch this, right? So this would become a 5 cubed up here and a 6 cubed up here. So what we would do here is we'd say 5/6 x equals 5/6 to the negative 3. And that's how they got switched. So x is going to be negative 3. So when you see fractions, if they're displaced, just think about those exponent rules and those negatives there. Okay, let's do this last one. We haven't gone over e totally yet, but you can still use your exponent rules here for this one. Okay, so let's think about this, how this e got down here would be a negative, right? Okay, so we've got e to the x squared equals e to the 23rd times, let's make this e to the negative 132, just so we can rewrite that so there's no more fractions. Now, when exponents have the same base, you can add them together, right? So this could be e to the 23 plus negative 132, which is 121. $109. Yeah, 109, sorry. Okay. So here's how we're going to write this. So we're going to have e to the x squared equals e to the negative 109. I think it was supposed to be the other way around, but I wrote it wrong. That's why. We can still do the problem, but I think I was supposed to write it 13 or something like that. I don't know. Anyway, we'll do the problem. Okay, so what we're going to do here is then set the e's equal to each other, or set the exponents equal to each other. So you've got x squared equals negative 109, and then you're going to go ahead and solve. So you're going to take the square root of negative 109, and that's going to give you plus or minus I square root of 109. Can you simplify the 109? I don't think we can. So we're going to leave it like that. And that one's a hard one to really check. But you can plug that in your calculator if you want, the negative 109 here, because when you square it, then it can become positive. Okay, so as long as you're following the exponent rules, you should be okay. So I'm going to stop here for this section. I'll finish the next section in the 5.4 video.